Alright, welcome back. This is Mike with my DIY channel, and today I was going to do a video on the titanium EasyFlux 125, but this time some on tips and tricks. And if you want, subscribe, like this channel, and you'll find other videos on some modifications I've done on the titanium. You'll probably see some of those. I'm not going to actually do a lot of welding, probably none. There's plenty of videos out there to how to do welding, and I will give you some tips though on how to make your welding look a little bit better. So the first thing we have to understand about the titanium is this is not structural or industrial welding that we're talking about. If you were into that, you would not be watching a YouTube video. You probably would have gone off to an official university or community college or trade school or something and professionally learned how to do welding. And also you wouldn't be using a titanium EasyFlux 125. Not to say that it can't do good welding, it's just that it's not going to be used for main structural or industrial, but it can do up to pretty close to 1/4 of an inch thick. And if you think that that's not very thick, put it in perspective. The frame on a normal car is only up to about 3/16 of an inch. So there's a 1/4 of an inch, 3/16 is pretty thick stuff. You can do a lot of great welding. I've done stick, oxyacetylene, MIG, TIG, whatever, pretty much every kind of welding. I actually like flux core the best. 90% of what I do, I can do with flux core. Now, another reason I like this welder is also because it's fairly inexpensive. It's got great quality, it's clean, it's DC, and so anyway, so remember that our objective here is just to put two pieces of metal together, right? Which also brings about when you start looking at videos about stacking dimes and how pretty it looks. Well, what you should be saying to those people is, I'm really proud of you, and who gives a shit? Because stacking dimes, okay, it looks pretty, but it doesn't necessarily mean it's any better of a weld. You can go ahead and weld and get two pieces to stick together for what we need to do. And as far as the stacking of the dimes, in time, the more you do it, the more you practice, yes, you'll see it. It's going to be a better looking weld. And those dimes, if that's what you care about, will come along just naturally. It's going to work for you. But for us, it's basically sticking two pieces of metal together. So the first thing we need to do about tips and tricks is to realize the quality of the wire matters. And that quality, there's two types of wire for flux core. You have the GS and then you have the 11. So that would be like the E71, I think it's E71 T dash GS or T-11. The GS is general purpose and S means single pass. Basically you weld something, that's it. Whereas the 11, like the Lincoln, or, well, there's a lot of brands. Lincoln, I prefer Blue Demon because it's about half the price. G11 is a standard from the American Welding Association and Society, whatever. It meets a certain standard and you can do multi-passes with it. So the first thing to realize is if you're buying 11 wire, you know, the T11, it doesn't matter the brand. Get whatever you can afford and whatever's cheapest, because it meets a standard. They all will work the exact same. GS, on the other hand, every manufacturer, there is no standard. They make it the way they want to make it. I've used a lot of them, and Forney is, in my opinion, the best. It's hotter, it's cleaner, it's great on thin metal, especially for something like this. We're going to be doing a lot of thin metal, so they're good. For the 711 or T11 multi-pass, I use Lincoln sometimes, but mostly Blue Demon. You can get the 2-pound roll for the same price as a 1-pound roll of the Lincoln. So once you've got that, the next important tip is the clamps. And we'll get to that in just a second. Okay, so your clamp, people will call it a ground clamp, but we all know that it's actually the positive because this is electrode negative. That's what all flux cores do. You've seen a lot of videos about get the best ground clamp. That's true. You want to get a good ground clamp. So let's not talk too far on that. But what is important is that the ground clamp is connected with the best possible connection to the metal you want to weld so that the electricity can have the cleanest flow of electricity. Now I use 3 or 4 different types of grounds. And if you look at my other video on modifications, you'll see why I have a DINS plug. I swap that out on the titanium so I can ground my bench. I can have different grounds. But if you're working with flat metal and that you're going to weld and you're going to have it on a welding table, definitely have the table grounded. The more surface area you can get on that piece of metal you're welding, the better the current flow, the cleaner the welds will be. If you have a really bad connection and it's sporadic, spotty, your welds are going to be spotty. They're going to be sporadic. It's going to be hot, cold, cold, hot, hot, cold. You want a nice level surface for a flat piece so you can get the constant current flow through there, because the current goes from negative to positive. So you have an electrode negative torch, it's going into that plate or piece of metal that you're welding through the table, whatever, back to the machine. Now, if it's something that isn't flat and you're going to have a clamp on it, regular earth clamp, then make sure also that there's no paint or rust. You know, wherever you're going to put that clamp, make it as clean as you can. The cleaner you make it, the better the weld's going to be, because it's not trying to be sporadic on that current again. Current flow is everything to welding and plasma cutting, but especially on welding, you need it to be consistent and the max current that you can possibly get out of it. Now, there's going to be times maybe the metal that you're welding is like different shapes or whatever, and your ground clamp can't do it. There's nothing to say that if you have that clean spot that you can't get yourself a nice firm set of, say, vice grips, and you clamp onto the piece that you're welding, and then that you take your return path for the welder, the ground clamp, and put it onto that vice grip or whatever. There's nothing wrong with that. I mean, just do the best you can as you can do it. The key, though, is get a good ground on this thing. If it's a painted surface, you know, sand off some of that paint, grind off some of that paint. Same with rust or whatever. Just get yourself the best grounded surface that you can. Next in line would be your settings. When you go ahead and do your settings, use the settings that are on the lid when you open it up. Use those as a good starting point. I recommend whatever they say, go slightly a pubic hair colder. It's better to do that. You can always weld back up again if you need to. But remember that these settings are supposed to be a ballpark, but I have found using this machine a lot of times that almost all of them stay in the same position. If you look at the numbers and the letters, it'll be about that. So voltage and wire speed, which is your current, most of the time I set them together, 8 o'clock position, 9 o'clock, 11, 12, 2, 4, whatever. I usually keep them together. I use the chart to get me in the ballpark, maybe go a little colder, slightly less, but just use those settings. They'll get you there. There's nothing wrong with getting a scrap piece to experiment with. And with those settings also is the stick out. You want to make sure that the stick out, that's the wire that's sticking out of the lead of the torch. You don't want that to be like this long sticking out. But at the same time, you don't want it to be here. You want it to be around, 3/16, quarter of an inch. And you've got to practice getting that to stay in that same area. If you can do that, then you'll be able to get a nice good weld all the time, and everything will be fine. And after the settings, once you've got that figured out, we'll talk a little bit about when you're welding two different size pieces of metal. Maybe you're doing a 1/4 inch with 3/16 or something like that. So we'll get back to that in just a second. So the settings for welding a thicker to a thinner piece, first, you don't want to go drastic. I mean, you have to be very careful. If you're using like the max 1/4 inch, but you're trying to put like 16 or 18 gauge metal to that, it's going to take some practice. But normally what you want to do is set the settings for the thicker of the two pieces of metal, and then when you're welding, concentrate on most of your heat being on the thicker piece. A butt weld is easy because normally when you are welding, whether it's a straight line or if you're doing back and forths, or if you're going to do what they, the circle E's, what do they call it? You're normally going back and forth with the same amount of heat and everything to both pieces of metal. But if you have say a 3/16, 1/4 inch, 1/8 inch, whatever, and a much thinner piece next to it, you got to teach yourself to go like more to the thicker side than to the right. So instead of going like this, a back and forth, you might go 1001, click back over, click back over, click back over. You understand what I'm saying. Longer on the thicker, shorter on that. That will help do it. Now, if they're dramatically different in thicknesses, like 1/4 and 22 gauge or 18 gauge, you're going to have to do a lot of practice in there, because what you're going to need for the penetration on the thick stuff, if you spend even more than a half a second on the thin side, you're going to burn right through it. So you're going to have to practice. But the thing is, you can't set it for the thinner because it will not penetrate into the thicker metal. So you have to work with the thicker metal. And if it's not structural, that's okay. If you're not going for something that needs 10,000 pounds of pull on it, then you don't have to penetrate the thicker metal as deep either, right? There's no law that says you have to go to full penetration. If the settings say, well, for the 3/16, you set it to like F5 or whatever, far to the right, but for the thin stuff, it's much on the lower end, but it's, just for a bracket or something that's hanging on the wall or a picture frame or whatever, and it's not major structural, turn it down. Don't penetrate that thick one as much, and then it'll be easier to go to the thin stuff. You don't want to go all the way to the settings for the thinner, but at the same time, you don't have to go to max for the thickness either. Also, a good thing about butt welds, while we're on it, is that even though the machine says you can only do, say, 3/16 to a 1/4 inch thick, with a butt weld, if you know what you're doing, you can double that. Because all you have to do is bevel your edges of the two that are coming, but also bevel the bottoms. So then after you do that 3/16 or a 1/4 inch weld on the top, flip it over and do the other side. 1/4 inch, 1/4 inch, you can get up to a 1/2 inch. Now that's not easy to do with, other kinds of welds, but on a butt weld, you can definitely increase your depth to get almost a 1/2 inch of welding out of this. Burn through. When you have that thinner piece of metal and you tend to burn through it, two things you have to look at. Maybe possibly lowering down the settings some more, but also travel speed. Go a little bit faster. And thin metal, maybe you don't want to go the back and forth or the circle E's. Maybe you want to do more of a straight line. It depends on the type of the metal, if it's galvanized or if it's just regular medium steel or if it's, a rusted iron. It depends on the type, but it's easier sometimes to just kind of do a straight. Now, if it's super thin, like it says, the chart says 18 gauge is the thinnest, but I've done 22 gauge. Nobody said that you have to do a complete bead. You know how you tack one side and you tack the other, right? Well, there's nothing that says that you can't do those spot welds all the way across. If you have a piece of metal like this and it's 22 gauge or whatever, tack weld it. go to the other end, tack weld it, go in the middle, tack weld it, split the difference between the top and the middle, tack weld it, split the bottom to the middle, tack weld it. Just do tack welds, okay? You can do tack welds and no problem. If for some reason you do need to make something a little bit longer or cleaner, if it's flat, what you can do is, I recommend, get on Amazon or whatever and buy yourself a piece of copper plate, copper bar, something that's like a 1/4 inch thick. If you lay that thin metal on top of that and clamp it down to the copper will soak up a lot of that heat. So you can set the settings and weld it, and because the copper is right behind it, it won't blow through, and the copper won't let it weld to it. So you're great. Nothing wrong with that at all too. Again, we're not dealing with structural and industrial welding. We want 2 pieces of metal to come together, not burn holes through it or whatever. You know, if it's flat now, if it's thin stuff, thin tubing, and can't get copper behind it, look at those spot welds. Just do a bunch of spot welds. There's nothing wrong with that at all. So I've actually gone from all the way up to 22 gauge, the thinnest, and like I said, I've welded up to 1/2 inch metal. So recapping basically some of these tips and tricks is the settings. And if you're going with 2 different size metals, go to the thicker settings, or the settings for the thicker metal, work your way back down. Use quality wire, Blue Demon on the 711. For the GS, I go with Forney, but you know, experiment, find what you like. But I found those 2 after using a lot. Those are great. Don't worry about the looks. Your objective is to make 2 pieces of metal come together. The looks will come. The more you do this, the more you practice, the more you weld, pretty soon you're gonna say, damn, that looks pretty decent. And then the next time, damn, that looks even better. And the same thing with the single pass versus multi-pass. GS, like I said, it's single pass. But if it's not major structural, once you've welded, if you say, man, I'd really like to weld that better, take a wire brush or take a wire wheel, clean that really, really good. And there's nothing to say that you can't, with GS wire, weld over top of that again. Okay, make it cleaner and thicker and whatever. It's just that wire wasn't meant, again, for structural and industrial type welding. It was made for a single pass. But you know, you're dealing with different kinds of welders. You're dealing with MIGs and 240 welders that have a lot more power, that can do a lot more. Just like there's MIGs out there that with this GS wire, it's made to weld 22 gauge wire. You can get really thin stuff. You don't always need a TIG to get to that thin stuff. But we're talking about the titanium and clones to it, and similar ones that are in that 120 volt up to about 100, 120 amp range. So the dimes will come. There's nothing that says that you can't, you know, weld back over it. But if you do, you gotta wire wheel that thing really clean, get it done. But the most important of all the tips is that ground. That ground has to be clean. It has to be clamped good. If it's flat, use your table, but make it and clamp it to the table and make it really get good electronics, good electrical flow going through there. That current needs a good path. If you can't because it's tubing or something, there's nothing to say you can't use, you know, vice grips or something like that that's hold on to it, and then take your ground clamp or your, you know what I'm saying, the earth, and clamp it to that. Use that. Again, butt welds. If you can do butt welds, you can double your thickness. You can go up to a 1/2 inch by welding both sides, you know, flipping. And then again, with the thinner stuff, feel free to do spot welds. Feel free to put copper behind it and clamp it down if it's flat and you can weld it. There's so many things on here, but I hope these, if nothing else, these tips and tricks have taught you not to worry about the looks of it. Get the metal to stick together. Do a clean ground, and if nothing else, think outside the box. There is nothing wrong with doing it. As long as the metal is going through and it's doing what you want it to do, and the 2 pieces are coming together, that's all that matters, right? So anyway, I hope this helps. If you have any questions, drop a comment, and check out my other videos. Have a great day.